Welcome to the pre-recording of lecture 25 of MCS 260. So this is the first half of the 13th session in this 8-week summer course. It is the third lecture on modules and packages. So we started this 2 lectures ago. So this is the third lecture on modules. So this course still follows the weekly schedule from a regular semester. I will say more about open source software, and I will try to define it, and also saying something about how to make your own packages. And I will end with the practical aspects of writing code in pairs, something that we will also experience in this course. Okay, so what is now open source software? And let's start with the history. At the very early beginning, the software was actually already free, but it came with the hardware. One had machines that or software that was actually tied to the hardware. If you wanted the software, you had to buy the hardware. In the 70s, hardware and software became decoupled. Also, software became a commercial product. The important aspect is also that in the early beginning, there was actually not that much a difference between a user and a programmer. But in starting from the late 70s, increasingly the users did actually not program. One of the important softwares are, of course, operating systems. So operating system Unix became a commercial product. And what actually happened was that the people who developed the software were kind of excluded from the benefits of that commercial project. So as a as a reaction to this, there is the GNU, which is not a Unix project that is started. And this also gave rise to the general public license, which dates back now quite a while. There is the free BSD, and there is also Linux. And that was beginning in the 90s. So open source in this course is mainly geared towards software, but there is also open courseware at the Massachusetts Institute of Technology. So the openness of information also applies to um, other than not just source code, not just software, but also applies to other domains of knowledge. Um, what are licenses essentially doing? They are essentially protecting intellectual property right, and the intellectual property rights should actually be protecting the efforts of the authors. So there are licenses, but there are other tools to protect intellectual property. The first one is very obvious. It is a trade secret, so you essentially do not release anything. So the and recipes for let's say baking some world famous cookies, the secrets recipes are completely kept confidential. Um, there is also the trademark. Um, that is also used, even if you would come up with something that very much resembles the actual product, the actual, um, now again, the example of a cookie, even if you would manage to make a cookie that is very similar to the secret cookie, then you would still not be able to call it that the name of the original cookie. So because that is trademarked. Then there is uh, then there are the copyrights, and then there are patents. So a copyrights actually grants the authors the exclusive rights to copy the software, to sell, to give the rights to others to distribute the software, modify, translate, etc. Patents also give exclusive rights, but they apply more to other products, for example, medicines. And the role there is that patents kind of protect the investments of the authors. Software is kind of different in the sense that with a good, there's actually physically a good. So think about a car. If you allow somebody to use your car, then at that time then you cannot use the car. So often with goods, there is the exclusivity of the good itself. Software is different because if you grant somebody else the right to use the software, then you could still also use the software. Um, so, in some sense, intellectual property rights apply to a lot of goods, but software is kind of special. Um, Even if some, if even if you can, even if some licenses may also essentially forbid reverse engineering of the code, or in some software packages you can see how the algorithms are implemented, but you're not allowed to take that algorithm as it is coded in that particular software package and take that out and actually make your own software package with this. Okay, first, before we get into the copyleft and copyright, um, why would you want to provide open source? There is the right, so there is the right, so the prime quality on software is correctness. And in many applications, so one can think of applications in science where things have to be verifiable. It's not so that in science everything is always 100% correct, but you can check its correctness. So that is important there. For mission critical applications, one needs to be able to prove to the user that the software is actually correct. There is the second, what is in red here, open source software. Sometimes people say what is free um, is often not really what it is worth, but that is actually not really true. If there is a user community, a developer community in this, then bugs can be fixed very quickly. So the free comes with responsibilities. So it's of course also often free as in free beer, so you don't have to pay with this. But the freedom also comes with certain responsibilities and certain obligations. Um, Software is also often seen as a service. Okay, typically licenses tell you what you shouldn't be doing. Copyleft is actually the opposite of this. So actually tells you, it actually gives you the same rights as the author has, which is not what copyright does. It grants you certain privileges, but it doesn't equate you as the user to the author. The first important thing is, however, is that you must, I mean, actually, probably I should have, before you can actually apply a license, you must actually make sure that you are the author and that uh, you actually have that the proper intellectual property rights. So, but copyleft works in these three steps. So you first have to state that the code is actually subject to copyright. It's not in the public domain. So that's also the difference between public domain and open source. So that's an important difference as well. So everybody else has the same rights as the author, but actually it comes with the third point. So you only have the same rights if you are not going to change the rights, the copyright. So in some sense, once software license is attached to um, to a software, any modifications and derivations of that software package have to follow that license. Okay, so here is a scheme of the differences. So it is a simplification with some very important examples. So in the extreme domain, at the extreme, we have the public domain. So public domain means that everybody has rights to it. So earlier in the course, we mentioned the project Gutenberg, so which contains many classic texts for which copyright has expired because the authors have long passed. So HTML is one of the conventions which is in the public domain. At the other extreme, at the other end, we have the proprietary software. So Microsoft Windows is one of the examples to this. Between the open source, there is the distinction between software that is copylefted, in the sense that you, that means that the users of the software, if it is copylefted, have the same obligations when they make modifications, that they also need to release the modifications under the same license. There are many permissive licenses which allow that you distribute modified versions of the code without having to release the source code. Apache, the web server, is one of the examples of this. Okay, so there are these four categories. So the extreme ends are quite obvious. So what is in the public domain and what is proprietary. It is rather often a little bit subtle between the open source, whether it is a copylefted license or whether not. All right, this brings us then also to computer ethics. So intellectual property rights form an important part of ethics. So if you are the author of a software, then it is seems extremely wrong that you don't stand to benefit from uh, every benefit that the software may bring, especially also if you are a scientist and people improve on your software, but you don't get to see what the improvements really are. Um, Computer ethics is important because of its impact on society. Um, the benefit, point 7, is again important. Uh, There is the trustworthiness of information. There is the personal information, the privacy. There is the freedom of speech. That's another aspect of computer ethics. One of the exercises recommended for this lecture is that you read the ACM Professional Code of Ethics. Um, okay, so that's the licensing aspect. So what you do need to know in this course is definitely the distinction between what a license does and what intellectual property is, and the distinction between copyleft and copyright. Okay, in the previous lectures, we introduced programming in the large. That means programs that are distributed over several files. Um, Packages are collections of modules. We can distribute a package. So here are the characteristics of packages. So there are three main attributes in any module. I'm here listing the mat module. There is a documentation string in any module. There is the location of the file, and then there is also the name of the package. Uh, Related to this are the functions locals and globals. So often you may want to check, or perhaps not, if you are including a lot of packages, your namespaces may change. So if you import py from mat, or if you have numpy that has another pi sitting in there, and sympy has the symbol pi and symbolic computation, you may want to check whether certain symbols exist within or are already defined. So you can actually check if you are importing a package. You can be conservative and import the package only by its name, but that is actually not sufficient. As we will see, as a package author, you can actually, as part of the initialization, you can actually import already in the namespace a lot of symbols. And you can actually change things. So locals and globals allow you to verify which names are already defined. This is often important within the context of a function. If you start to evaluating source code, assuming that certain values have been set or certain constants have been set. So you can actually, as a programmer, you can check if these variables are already defined before you may yourself do something with this. All right. There are packages that have sub-packages. So NumPy is a very extensive package, and that has many sub modules or sub-packages. So there is the linear algebra, the linalg of NumPy, which allows to do arithmetic with matrices. So you can multiply matrices, add them together. Um, okay, so how do we make our own package? So we had the first collection of modules that were wrapping a stack, and then we wrapped the queue as an exercise. That's still an exercise that will be collected. There is then the automated quiz on computer literacy concepts. So we had 4 files. Uh, there are several steps that you need to do. Um, have here listed them as 6 steps, but you can group them in groups of 3. It's actually there are 2 major steps. There is the definition of the folder. I mean, think first about a good name of your package. Think about an initialization and test the import. So that's what you do locally in preparation for making your own package. When that works, you can then have to um, define essentially the setup, and you have to test the build. That's still something that you do in preparation. Then you can install the package. All right. For the next project, you will be allowed to work in pairs. So in programming in pairs, there are 2 main methodologies. So there is pair programming, where two programmers share the same computer and are synchronized. So there is one person who codes and another person checks or makes suggestions on how the code should be written. So there is a driver and a navigator. It's like in a car where you have somebody in the driver's seat and then the person next to the driver navigates, reads the maps. Reading maps while driving is not recommended. Often, like in a road trip, people switch roles from time to time. So this is pair programming, where you do things synchronously at the same time, same computer. There is the, I wouldn't say opposite, but kind of the orthogonal approach to this. The other dimension, this is code review, where two developers share the code. There is one coder and there is one reviewer. So again, there is the version control that plays a role here. So in order to make sure that only one version of the code changes, there's only one person who is the coder and the other person reviews the code. And the roles actually also switching from time to time. Typically, this happens when people cannot be in the same room or often not in the same time zone. Um, when and the roles are actually also combined. So it is often the case when somebody codes after reviewing what the partner sent them. So these are orthogonal approaches, but they can also be combined. Sometimes the collaborators can join and meet together and look over the code. All right, so the main exercises are mainly thinking about licensing. So you can visit these two websites. Um, the discussion about open source and ethics is certainly still very actual with the use of machine learning resources. Is it ethical to use proprietary and even open source materials to train um, artificial intelligence, uh, which is then often considered closed source as well? Um, Oh, what about the Python license? Compare the Python license with GNU GPL. So we said that Python was actually open source. It's an open source project. Look at the license for Python. Is it compatible with GNU GPL? You can change the module search path. So there is the professional code of ethics. Please read it and uh, write a paragraph to summarize what actually. Um, so this is also code, but it's code meant to be understood by humans. Uh, Write one paragraph to actually summarize what you think is the essence of the code. Um, there is one action item. So if you are taking a linear algebra course after this, the NumPy is a very well used Python package to do numerical computing and and solving linear systems in particular. Okay, in a way, this is the most important slide of this lecture. So this lecture invites you to explore. I have one Jupyter notebook. So this Jupyter notebook is rather sparse. In some sense, it's a reinforcement of what we have covered in the earlier sessions. So, but now I have two sections, the two major steps in the preparation of making a package. So the software that we write in this course is not really up to standards to distribute into a big package, into something that other people might use. but it's good to know that you can bundle your code and into a package. So, for example, all the scripts that you have developed for this course, put it in a folder. Here I illustrate the two important first steps. So you have to think about a good name for your package. Um, See that you don't run into trademark issues. You have to make a subfolder. The name of the folder is the name of that package. So that's why this step is often a very important step. The other step is that you have to provide an initializers. And in the initializer uh, defines what you do when you import. So last time we said that the quiz only had one loop as what was in the main program. There was not even a main program. Here, therefore, I will not run the quiz when I import it. I will just write a greeting. Okay, so these first steps, what you need to do is you need to make a subfolder. Here I made the subfolder in the subfolder of lecture 25. So this is AutoQuiz. So AutoQuiz contains the files that we considered last time. So if I do pwd, this shows me the absolute path name. So this will work as well on any Mac and any Linux computer. What you see there, you copy and paste, and you as the second argument in the insert. On Windows, you have the double backslashes. So what is new is the init. So if this goes well, so let me show the init in the auto quiz. So the init is just a welcome. Here I am importing the quiz, but I documented it out. So the quiz essentially exports only one functionality, and that's the running of the course. So it's just a terminal based application. So if you are working in a terminal and you're importing this, then you don't mind that the quiz runs. Otherwise, you import a module, and from the module you then import the quiz if you want to run it. So let me illustrate this. So here, of course, it is well, let me illustrate this, how also here I need to insert the path. So from sys import path and then path insert the entire path. So now I'm going to copy and paste from what I have in my Jupyter notebook. So if you develop source code, for the projects, you must provide a .py file. So the goal is actually that you develop a .py file. And this is here a test on how you would test out the instructions as you type them into an interactive shell. So if I now do the import auto quiz, then you see the welcome. I can now run the quiz by importing auto quiz. So that will run the quiz. There is no main function. There's actually no function at all in this file quiz. You could name the function and you could then import the main from the quiz, or you could have a function quiz. But here is just a quiz. So that will run. So here I'm now guessing how many bits go in 1 byte. Just 8. I don't want to continue. So here was just the main point that I wanted to make. How do you test this? That this first step, putting everything, all the modules into a separate folder, and then writing the init. The underscore init. So that is a built-in that we will see also in a different context when we start object-oriented programming in the second part of the session, here scheduled for the next lecture. All right, that's the first step. Think about the good name, organize your modules, and write an init. Then the second step is to write the setup and do the build. So the build will actually make the package. So in the setup, you will have to think again. I mean, you are the author of the package, but you have to think about the short description if you don't have that already. You should also think about documentation, but that's a separate aspect. You should think about the version number. There are conventions about this, so there is also there are the several letterings with dots. Then there is also the alpha beta. Alpha is that it's only intended for like-minded people. Beta is for beta testers, and if you leave that off, then it is a general release. Um, you have to define in the setup the packages, again the name, and all the modules that you export. You can also export data. So sometimes there is test data. The license is important. So, and in some sense, you should actually certainly, if you are coding in an organization or you're coding for compensation, you don't code in a course, but you should actually think about what the license should be before you start writing software. So, but certainly you should not release any software and then all of a sudden think about, oops, I have forgotten the license. So the license is also important here. Then there is the platform information. So our code is pure Python. It doesn't really matter that much, but sometimes the initialization can take into account the specifics of the platform. Sometimes you can export also shared objects that are particular to a certain platform. So what are good values for this platform? Well, look into your OS. What is the operating system? So import the operating system and look for the name. So for Windows, it is NT. Both for Linux and Mac OS X, I tested this, the OS name will be POSIX. POSIX is for portable um, system information. Okay, this is a relatively short lecture. I'm actually done here, except that I should show the setup. So the setup is part of the package essentially, but it's not part of the folder. So in some sense, this is not entirely complete. So typically you have another folder. So you have the folder with the name of your package. You have then the subfolder with the source. And in the folder of your package, you have actually the setup. In that folder, you also have the documentation. So typically in any package, and that's actually important. So what we are doing here in this course is preparing. So I should actually have indicated that there is a step 3. So there is the package folder. So what does the package folder do? So the package folder contains is what will be distributed. So this folder contains the following. It is containing the source, Typically, SRC is the source code. Two is the documentation. Uh, we will probably talk more about documentation. So every documentation consists of four parts. There is the installation guide, the getting started, the user manual, and then the programmer's manual. So writing documentation, writing good documentation is very important as well. But in essence, your package folder should contain the setup. Um, so this defines the build instructions. And there's actually a lot more. Especially you should have a README file with information about the software. General information. This could be very short. It could be that your documentation contains all that, but sometimes in any folder, it's good practice to have one README. So this is the first place to look. And then actually license. This contains the original copy of the license. So if you have the GPL license, so these are five parts, and in preparing this Jupyter notebook, I skipped this. The license, so when you say that your software is actually GPL, then you should actually also provide the user with the actual text of the license. The point is that the distribution should be as self-contained as possible in order not to have any ambiguities. So there should be. I'm not. I'm mentioning versioning here. It's good. So this is the preparation. So these are the three steps in preparation of preparing your package. We may cover the version control and the documentation and testing in a later lecture. But these are the essences on how packages work. Okay, so this is to say that the setup is actually in the uh, package folder, which is source code, but in some sense it's not part of the source code. It's more information about. So here you see the name of our package. It's called AutoQuiz. The author, I just give the name of the course. Um, for my practical purposes, it's actually very much. I here recommend the GNU GPL license, but it's actually very much also in the public domain. So this is not important software, or um, it's for educational purposes only. There is the package, so there could be multiple packages. As far as the versions goes, so this is still version 0.0.1. So typically there are many iterations. So we saw the spiral model. This would be the first step in the spiral model. So this was still something that I wrote and without very or little or no revisions. I once wrote, and it has not changed much. So uh, the version number, so the triple, so the dots actually mean something. If you go to version 1.00, or if you go from 0.9 to 1.0, you expect important changes. It also indicates stability. So going from 1.2.1 to 1.2.2 may not mean much. It may be mainly a bug fix or something that matters to the programmers. But going from 1.0 to 2.0 typically has important changes. In Python, we had the going from Python 2 to Python 3. So there was an important difference. Okay, I'm close to 40 minutes now. There is much more that could be said about the topic of licensing, packaging, ethics, and more in general about software development and packaging. I will leave it here. Um, in the actual session, this will be the shorter part. What comes in the second part is actually more important, the introduction of object-oriented programming. Okay, I'm at the 40-minute mark, and my voice is kind of not good anymore. So I hope, nevertheless, that you understand the critical difference between. So this diagram is very important. So I give the source. So this comes from a book about open source. So this is the slides themselves are actually not really um, my intellectual property, but this is educational use. So I think that it is proper to use. But this is an important distinction that you have to know. And please read the Code of Ethics for the ACM. So in this course, we are all becoming computer scientists, and it is important to reflect on what is good professional behavior.